Mike Harmon over at the HLModtech channel offered a design challenge in Tinkercad to produce this. While he really likes using the sketch tool, I like using the blocks and shapes, but more than that, I really like using the code blocks tool so you can go in and change a few parameters and redesign it automatically. So let me show you how I designed this to meet his challenge using blocks and then convert it into a code blocks that I could give to someone who doesn't even know how to CAD and can change it to whatever they want. I'll explain it all on today's Filament Friday.
This video is sponsored by PCB Way.
Now, I found this to be a very interesting challenge, and he supplied an image that you could download. I downloaded it and printed it, put it next to my computer, and it's got all the dimensions, including a 3D view of the object that he's challenging us to make. Now, I know he's a fan of the Tinkercad sketch tool where you can draw in 2D and then extrude it, which to me is just like kind of similar to Fusion 360, where I'm more of the type that likes to take blocks and put them together. I've used CAD, I'm an engineer, I've used it, but I love how I can just take blocks and shapes and put them together. Now, I also do a lot of electronics, write code, and so Tinkercad Code Blocks are fun for me because I can take the steps that I use the blocks to build something and turn it into steps of Tinkercad code to build it automatically, and then it becomes a parametric design. So I'll show you how I built it with blocks, and then I'll show you how Code Blocks builds it automatically. So I open up Tinkercad, and the first thing I do in any design is I drop the ruler onto the bed. Now, I'm not against dimensions, but I want a base to work from. So I put down the ruler, and from this I can adjust any sizes and verify things. The first step is to use a box shape. I'll drop it on the bed, and then I'm going to use its properties window to set the sizing. So the length is 40, the width is 60, and the height is 10 millimeters. So that's all off his drawing. And now I've got the base that I'm going to use for the shape, the challenge shape. And I'm actually going to change this to 0, 0, so it's right at the corner of the ruler. So everything's referenced off the left corner. So next is to bring in another box shape, but before that, I'm going to drop the bed on top of this one because I'm going to build from here. So now the bed is actually offset 10 millimeters. So then I bring in another box shape, and I'm going to adjust it here, again, by the properties window. So I'll set the width to 30, I'll set the height to 10, and the length to 10, which is what his dimensions call out. Then I'm going to use the alignment tool and click on the base and make sure it's aligned with the corner of the base. So perfectly lined up. Next, I'm going to bring in another box shape on the other side. Now on this one, I kind of screw up. I clicked on that number, and then I went to the properties window, but when I changed it, it changed into the little window here at the shape. So the properties window didn't change, so that's kind of messed up right there. I wish Tinkercad would connect those two better. So if I change one, the other one changes. But anyway, so now its width is 30, the height is 30, and the depth is 10. And now I just need to align this. So I go back to the alignment tool, click on the base, and then I just line each corner. So the back corner of this thing is lined up perfectly. So now I got 2 of the 3 shapes popping up. Now I got to put the hole in place. So I bring a hole piece, and again, use its properties window and set it to 10, 10, and 20. And then I want to offset its base by 10 millimeters. So it's off the top of the base, and then I just slide it into place, and I now have my 10 by 10 hole, 10 millimeters off the base, already in place. Now there's an angle at the front of this, so I'm actually going to bring in a triangle shape, and this doesn't have a properties window, so I got to do everything right here off the ruler tool. First, I grabbed the rotation tool and turned it 90 degrees, and then I made its depth 10 millimeters. Now I need to make it taller, 30 millimeters per his drawing. And now my screen cut off here, I made it 20 millimeters wide. So here you can see, I set it to 20 millimeters, but that was cut off. Now I bring the base plate and lay it against the side of that block so I can just drop that piece. I hit the D key and it drops right against it. And now I just use the alignment tool to align these two together. So I click on the big block, which I'm trying to align to, and then make sure that it jumps over to it's lined or centered to that block. And now I've got the angled block. So all that's left is the corner block here, but I'm going to take away material. So I brought in a triangle piece, and I'm going to turn this twice. I'm going to turn it 90 degrees in one direction, 45 degrees in another direction, bring it over here to the corner, and then I'm going to align this and make sure that it's actually at the corner, but I actually positioned it perfectly. So you can see it's gray dot, so it's in line. And then I turn it into a hole, and now this thing is done. I just need to group everything together. So I grab everything, hit the group tool, and there's the design created. Pretty simple. I mean, I don't think this took me more than 15 minutes to do. Now, I'm always curious for someone who doesn't have a 3D printer, what they would have to pay to have this done at PCBWay.com, which is our sponsor. So I can go right to their site, click on 3D printing, and I can upload this .stl file that I just made. And then I can test it in different materials. So I can also look at it in a 3D view. So it looks good, it imports fine. So what you design in Tinkercad does work with a professional service like PCBWay.com. And you can buy in quantity. So if I want to build 50 of these, say it's some bracket that I really need, I can get them for $5.21. But that's with a resin. What if I did PLA like most of us print at home? Single piece is just under $5, but 50 pieces, $3.24. That's not bad, but you've also got the option to do other materials that maybe your printer can't do, or even aluminum. You could 3D print aluminum. At least that's what they're here. I haven't tried this yet, but it's a lot more money. But the fact you could do this is amazing to me. So check out PCBWay.com. I use them for circuit boards. It's really cheap, but they got CNC machining, 3D printing, sheet metal fabrication, and injection molding. So I highly recommend you check out PCBWay.com. Now, as I mentioned, Mike likes to use the sketch tool. I'm not a big fan, but this is how you would generally do it. You bring the sketch tool in, it goes to a 2D view, and then you just do all the dimensions, all the edges, just like you would in CAD, even like you do in Fusion 360. And then it extrudes into a 3D shape. So I didn't do the design, his challenge, but this is just to show you real quick. But let me show you Tinkercad Code Blocks instead. If you've done any Arduino programming, you've probably seen this type of block coding. Well, here in Tinkercad Blocks, you can drag a box like I've done here, 2 different ones. You can set the dimensions, just like I was doing with the parameter window. Then there's a move tool, and there's a rotate tool, and there's a group tool. And you basically just build step by step the same way I did it with blocks. You develop code, and this took 17 lines of code to produce it. And now I can single step through it. You can see the block is made. You can see that first block that I did, the larger block that I did. I bring in the hole, position that to the center. I bring in the triangle, turn it, resize it, bring it up to its position. And then the corner block, it's going to take away material. I put that in place, 17 lines of code, group it together. I've got the design. That's that easy. This is why I love code blocks. All I did was reproduce the same moves that I did in normal Tinkercad. In fact, I ran into the same problem. Those triangle pieces, I had to do the dimensions separately because they don't have a property box. And so the property box is built into the command line for the box and for the hole. And so I step by step just made this thing move things. The only difference was I referenced the back corner as 0, 0 instead of the front corner. And then when I'm done, I just group it together. And once you've got it, you can make a little movie and show your design. Here it is just running as a movie. It just shows each piece in place, makes for a nice animation to show people how to build something. So I find this very, very handy to use. And once you get the hang of it, it's really not that tough, especially for a design this simple. Code Blocks is perfect. You click on the share button in the upper corner. You can do it stl.obj.svg, image or video, or a 3D shape. So all that is available to this. And if you want to change a parameter, just click on the little icon in the corner and it takes you right back to this where you can change a dimension. So let's say I want to make that hole a different size. I find that command line and then I go in here and change the dimensions. The width, I'm going to change it to 12. Height, I'm going to change it to 15. And this all works off the center of the hole. Every command is worked off the center. And so now it's going to redraw the whole thing, but it's going to put the bigger hole in place. See, right here. That's the new dimensions of the hole. Everything else is the same. And then it groups together, and now I have the same block with a bigger hole. All parametrically designed in Code Blocks. So that's my answer to Mike's shape challenge. I just use blocks to make stuff, but then I go step by step and turn that into Code Blocks. So then it's parametrically designed, and I can save that for the future. Now, what I really would love is Tinkercad to allow me to build with the blocks, but the whole time recording everything. So then it automatically, with a click of a button, turns it into code blocks. So I don't have to do the step by step. It automatically does it. It doesn't do that now, boy. I'd love to see that in Tinkercad. But his image is fantastic. If someone wanted me to design something in Tinkercad, I'd say, give me this. Give me a dimensional drawing with a 3D sketch. Do it by hand, do it on a computer. I don't care. But from this, I could design it in Tinkercad, as you saw, really easily, just by building the blocks. And then from there, give them the code blocks version. So they could just modify a few numbers and change it however they want. They don't even have to know how to use it. Just change a few parameters, let it run, and then export to that STL. That, to me, is what makes code blocks so amazing. And I just don't think enough people realize how handy it is. So I issue a challenge to you. Go try code blocks and let me know what you think in the comments below. I want to give a big thank you to my Patreon supporters. You guys are awesome. You keep the channel going. Thank you for your support. Thanks for watching. And here's a few other videos you might like. If you want to help support the channel, Patreon's the best way to do it. And if nothing else, click on that logo and subscribe. I'll see you next time right here at Chuck Hollenbach's Electronic Products and Filament Friday.